Okay, good morning. So I will not teach the next chapter. I think this one session is good if we practice some of the previous problems in the book. Some of them are hard. Okay, so if you remember, I told you to solve this problem. I don't know how many of you have thought about this. So I give you a little bit of time to understand this problem yourself. So the problem tells you that a straight line passing through the origin, which straight line is not mentioned. So a straight line passing through the origin intersects the graph of this function at 2 points. Show that the tangent lines at the intersection points are perpendicular to one another. So it means that they intersect, the tangent lines intersect, and the angle between them is 90 degrees. Okay, it's a good problem, and it's a level 3 problem. I also see that some of these type of problems are also there in the national exam, especially the last parts. Okay, so you think a little bit about this, and then we start solving this together. Okay, there are some problems I think it's worth it to mention it before leaving this chapter. Okay, let us solve the problem together. Okay, so a straight line passing through the origin is supposed to intersect that curve at 2 points. So the curve is given to be y equals to 1 minus 0 comma 25 x squared. And then we have a line that passes through the origin and intersects this curve at 2 points. Of course, it is good to have an understanding of how the graph looks like, but you don't need to be very precise. That's the whole point. So if I want to understand what the graph is, I know that x squared is this parabola. So I know that when I multiply it by minus sign, we studied this before, it will be reflected about the x-axis. And of course, if I multiply it by a constant, it will be squeezed or stretched along the y-axis. Okay, so it essentially doesn't change its nature. And when I add 1 to it, it will be shifted 1 unit up. So that is a good idea, actually, to understand what is going on. So that would be a parabola of this form. And if I ask you what this point is 1. And of course, if I ask you what are these points, you can calculate them correctly, yes? Exactly. How? Of course, my picture is not good. It should be very symmetric with respect to the y-axis. But I just tell you that you don't need to waste a lot of time to make it precise. You just need to draw a picture to understand what is going on. Okay? So you have to be able to convince yourself that this graph is of this form. And what is mentioned in the problem telling you that a line through the origin intersects this graph at 2 points. Okay, and it's clear. It doesn't matter which line I choose passing through the origin. It will always intersect my curve at 2 points. Yes, so let us take one of them. Of course, the problem is not mentioned which one of them we are supposed to choose, so we have to choose a random one. And then I get 2 intersection points, okay? And this is claiming that if you draw a tangent line at these 2 intersection points, of course my picture will be awful, but hopefully understandable. So if I draw a tangent line here, and if I draw a tangent line here, the claim, of course, is that this angle is 90. Yes, which of course in my picture is not at all. But that is the whole point. This analysis, you have to really be able to do it. Otherwise, there is no way for you to solve this problem. So first of all, tell me, is that clear, more or less, what we are doing? Yes? So what happens, this is a hard problem because we don't fix this blue line. How many blue lines, how many lines can pass through the origin? Infinitely many. So, for example, if I change my line to this line, then I will get 2 other intersection points. And then I have to draw the tangent line here and here. That will be 2 other lines. But if the claim in the problem is correct, regardless of what line you choose, the tangent lines are always intersecting at 90 degrees. That is what we want to prove. Is the problem clear? Yes, so it means that, so let me just review it again. So I have a curve. There are infinitely many lines that pass through the origin. According to the problem, choose one of them, no matter what. It will intersect the curve at 2 points. Draw a tangent line at this point. Draw another tangent line at this point. And these two tangent lines will intersect. I cannot draw the precise picture, but the problem claims that this angle is 90, regardless of what you have chosen in the beginning. If I start changing this line, then of course these points will change, and consequently the tangent lines will also change, but one fact remains constant, and that is the angle between the tangents. So we want to prove this claim. Yes, is that clear? Okay, so let us work with this awful picture, but hopefully understand it. Okay, so what do you do? Again, I told you how to analyze the problem. So the goal in this problem is to prove that the green lines are perpendicular. So that is the goal, okay? So the goal to prove that, so let me call this line L1 and L2. The goal is to prove that L1 is perpendicular. This symbol means perpendicular to L2. That is my goal. When you read this is, by the way, not hard, because that if you read the text in the problem, you see that your goal is to prove this. And then you have to ask yourself, how can I prove two lines are perpendicular? This is the question that you have to ask. Answering that question provides you a good strategy to continue the problem. So how can I prove that two lines are perpendicular? So you have to go back in your toolbox, your brain, and see that what you have in your toolbox to prove that two lines are perpendicular. If your toolbox is empty, of course, there is no way for you to continue. But if the toolbox is not empty and not organized, then you'll have a lot of problems finding the tool. But if your brain is full, if your toolbox is full and organized, you can find the tool easily. That's the whole point of mathematics, okay? So how can I prove that two lines are perpendicular? Go back to your toolbox. Yes?
The first line times the second line equals minus
1. What of the first line?
K.
K value. The slope of the first line multiplied by the slope of the second one should be 1, minus 1. Okay, so that is correct. So now this goal translates itself to a mathematical form. It means that I need to prove that K of L1 multiplied by K of L2 is what? Minus 1. Okay, so that is my goal. But the translation of this English sentence into mathematical symbols means this. So this is my question mark. Okay, so I have to concentrate to prove that K of L1 times K of L2 is minus 1. Okay, if I want to do this, the first thing that comes to mind is to find K of L1 and find K of L2 and multiply them to see if it is minus 1 or not. Yes? Yes or no? Okay, so now my new goal is to find K of L1. Okay, because I want to find that. So don't distract yourself. Your goal is to find K of L1. Okay, but how can I find K of L1? Yes?
Take the derivative of the original function at the point where line for 0 meets the original function.
Yes, so for example, what you are saying is that if I call this point A, if I ask you what is K of L1, so this again, you have to ask yourself, you see that you just changing your question over and over again so that you can solve it. Okay, so now your goal is to find K of L1. Okay, so then I ask myself, how can I find K of L1? Then I see my toolbox. In my toolbox, I know how to find the K value of the tangent line. Okay, so what does it mean? It means that the K value of this, if I call this Y prime, it is Y prime, but Y prime does not give me K value unless I have to put the X coordinate of the point of tangency, which is unfortunately that one is also missing. Okay, so let me call this one point A. Okay, and something here. So this point is also missing. If I can find that A, then this becomes Y prime of A. Yes? So you see, I want to prove that the lines are perpendicular. This is my goal. To prove this, I need to find K of L1. Then how can I find K of L1? I need to take the derivative, and then that's the problem. I have to find the x-coordinate of the point of tangency, which I don't have it now. But if I can find it, I put it here, I will find K of L1. But now, again, you see, again, I have trained my brain to forget about everything, concentrate on one thing, how to find A. So you see, if you start from here, you automatically are guided to what to do. Now I can forget momentarily about the problem and I concentrate on finding A. Again, I have to look back into my toolbox. How can I find A? In general, how can you find, because this A, what is the name of is A in English? I don't know. When you read the problem, what is A here? A is the point of intersection between the line and the curve. And if you want to find the intersection point between two functions, what do you do? Yes?
You said an equation.
Yeah, you solve the system. Yes, so you have to solve the system, okay? In order to solve the system, you need to have the equation of the functions. The equation of one function is given to you directly. So I would write y equals to 1 minus 0, comma 25x squared. This is the equation of this black curve. For the blue one, what do you think I will write? Yes? Yeah, kx, I don't want to use k, you are right. But if you don't mind, let us write mx, because I have used the letter k before. So be careful about these things. So this is mx. Do you agree? Any line passing through the origin has this particular form. What m is, I don't know. Okay? But this is the best I can do. Any questions here? And the reason that I chose letter M, because I have chosen letter K for the K values of the green line, so I don't want to get confused, so I chosen a different letter. Is that right? So then I have to solve the system. Okay? Solving the system means, as Matthew said, we equate them, yes? Because I have to eliminate one variable. Y is this one, on the other hand, Y is this one. I equate them, I get this equation. Okay, what is my goal? My goal is to solve that one. Now, this is not conceptual anymore. My goal is to solve this. So I need to know how to solve this. This is a quadratic equation. For example, I don't like working with fractions. If you don't mind, let me multiply everything by 4. Okay, so this becomes 4. This becomes minus x squared. This becomes 4mx. But don't lose the goal, okay? So what should I do? I need to solve this equation. I move everything to the other side, so it becomes x squared plus 4mx minus 4 equals to 0. Yes? Yes or no? Okay. If I solve this quadratic equation, I prefer to use ABC formula. So x becomes what? Minus b, which is minus 4m, plus or minus a square root of b squared, which is 16m squared, minus 4 times a times c, which is positive 16, and then divided by 2. Yes? This is the x. Okay, first of all, could you guess there will be 2 answers? First of all, tell me, are there really 2 answers? Yes or no? Are there really 2 answers here?
Yes, because it intersects on 2 points.
This is from conceptual, yes. You expect to get exactly 2 points because this will intersect 2 points. But is it really 2 solutions? Yes, one with positive sign gives you 1x, one with negative sign gives you another x. Yes? Am I worried about what is under the square root sign? Because if under the square root sign turns out to be negative, I do not have solutions at all. But then I will be in trouble. But am I? Am I in trouble here? Why? Because 16m squared is always non-negative, plus 16 is always positive. So I am on the safe side. So this is always meaningful. And then I have 2 solutions, one with positive, one with negative. Yes? But I prefer to simplify things as much as possible because I do not have m, and unfortunately I have to live with it. Okay? So it is better to simplify it as much as possible. So I'm asking you, so how can you simplify this? Yes?
Minus 2m plus or minus the square root of 16m squared plus 16 over 4.
No. What did you say?
Minus 2m
Yes?
plus or minus the square root of 4.
Yeah, that's correct. But instead of doing that, if you don't mind, let me factor 16 out. Okay, so if I factor 16 out, it becomes a square root of 16 m squared plus 1. And then I have divided by 2. But the square root of 16 is what? Is 4. So it becomes minus 4m plus or minus 4 square root of m squared plus 1 divided by 2. And of course, you can factor a 2 out and simplify it more. So it becomes minus 2m plus or minus the square root of m squared plus 1. Do you agree? Yes?
Should be a 2 in front of the square.
Yes, there should be a 2 here as well. Thank you. Thank you. Is that understandable? But what is this? I hope that you are not lost. So what are these numbers? This is a hard question, so the numbers are not numbers, they are parameters. Okay, so what is the interpretation of these answers? What are the interpretations of what I got so far? Don't lose the logic. So why I did this? Because I wanted to do what? Yes?
To find the y value of 1a.
No, not y value. X value. Okay, so these are x values. Okay, I called them a, but I hope that you are not confused. One of them is the x coordinate of this one. The other one is the x coordinate of the other. Is that right? Because what was my goal? My goal was to find the intersection points. In order to find the intersection points, I put this equation and that equation in a system, and I solved that. And when I solved that, what x I found are the x coordinates of the points of intersection. Yes? So one of them, which one I don't know and I don't care that much, one of them with the positive sign, for example, is the one for the right side, and the other one with the negative one is the one for the left side. Okay, so one of them, so yeah, I get 2 answers. Okay? Those answers. Is that understandable what I'm doing? Yes or no?
Yes.
Okay, so now if I ask you, can you calculate k of L1? Before doing k of L1, you need the derivative of the function, which is an extremely simple function to differentiate. So what is the derivative of y? The derivative of 1 is 0. 2 goes down, so it becomes minus 0, 5x. Do you agree? That is the derivative. And now I have to replace the x value with the x of the point of tangency. But I learned one of them is the one with the positive sign, the other one is the one with the negative sign. So I can say that KL1 multiplied by KL2 is, okay, can you help me what to do? I have to take this x and replace it with what?
Minus 2m.
One, yes, with that one. So it becomes minus 0, 5. I replace one of them with minus 2. For example, with the plus one, I don't know which one is which. Yes. Multiplied by minus 0, 5 with the next one. Yes? Okay, I want to wait for you to see if you understand. You see, don't want to lose. My goal was to find KL1 and KL2 and multiply them. In order to find KL1, I need the x coordinates of the intersection points. So this motivated me to find the intersection points. So I had to solve a system and find x values. I did that and I found these 2 values, okay? And now I have them. One of them is the x coordinate of one of these, and the other one is the x coordinate of the other one. Okay, now I have the x coordinates. I want to find KL1, I need to take the derivative. The derivative is extremely simple. I took the derivative here. In order to find KL1, I need to replace x with the x coordinate of point A. in order to find KL2, I need to replace x with the x coordinate of the second point of intersection. Okay, so I replaced x with the first one, and I replaced x with the second. Is that right? And then I have to multiply. Okay, so how should I multiply them? First of all, this is simple. This times that one is what? 0,25. Then I have to multiply this by that. So how should I multiply these two? It's a conjugate rule, yes? Because if you give the role of the box to this and circle to this is the same box and that is the same circle, yes? Box plus the circle multiplied by box minus the circle, yes? So the answer becomes what? Box to the power of 2 minus circle to the power of 2. Yes? Okay, then let us calculate. This becomes 0,25. This one to power 2 is 4m squared. This one to power 2 becomes 4 times m squared plus 1. But I multiply 4, there is a negative sign there as well. So it becomes minus 4m squared minus 4. Yes? Is that right? And then you see that the value of n does not play any role in this problem because whatever it is gone. And what is left for me is 0,25 multiplied by minus 4. But what is that number? That number is minus 4. Okay? So that was the solution to this problem. So calculationally, it is not very hard. But I would consider it a hard problem because you have to analyze the problem in a proper way in order to be able to solve that. Yes?
How, like the formula there on the question, is that, what graph is that? Is that L2?
The black one. You don't need to draw a precise picture, but everyone should at this level know what is yx squared. Yes? And then when you say minus x squared, it will be flipped over the x-axis. And when you add 1 to it, it will be shifted upward. And that is enough. You don't need to draw. You see, I didn't even have a nice picture there. Yes, is that clear? Okay, so might be it's a good idea if we also see this on GeoGebra here, using GeoGebra. So what I do, I will type that function y equals to 1 minus 0.25 multiplied by x squared. Yes, this is the graph, of course, similar to what I drew. And then the line is y equals to mx in my notation. So I would write y equals to, but m, I put multiplication by x. As soon as I press enter, GeoGebra actually faces some problem because GeoGebra will not be able to draw this one because m is not known to GeoGebra yet. So if you press that one, GeoGebra makes a slider for m. Okay, so this is the slider. So if you don't mind, let me change the color of this to a different, so that you can see it better. So this is reasonable. You see, as soon as I pressed enter, GeoGebra provided a slider for m, and now the m value is 1, so the y is equal to 1x, which is this red function, yes, red line. If I start moving things around, what will happen? I am changing the slope of that red line, so this will change, yes? Okay, and now my goal is to find the intersection points. In this case, I chose 0.8. It doesn't matter, we will see that. So I will go here and then choose intersect. I click on this one and I click on that one. I get 2 intersection points. Yes, so you see that if I move things around, the intersection points are changing. Do you see that? Okay, now I ask GeoGebra to draw one tangent line at this point, one tangent line at this point. If the claim in the problem is correct, the angle between these two tangent lines should be 90 degrees exactly, independent of the location of this red line. Okay, so let us just try understand that. I go here and I ask GeoGebra to draw a tangent line to this curve at this point. So I don't know, let me change the color. So let us make it, I don't know, purple. Is it visible? Yes. And then I asked GeoGebra the same thing. I asked GeoGebra to draw a tangent line to this curve again, but this point. Okay, so let me change this color again. So let us use the same color. And then, of course, I can find the intersection point between these two. And that is, I hope that you see this angle is 90. But if you still don't believe that, probably we can make it clear. So I should start from here, here, and there. So that angle is 90 degrees. Okay, but that is not the important point. The important point is that if I start changing the location of the red line, everything will change. The angle 90 remains 90 all the time. Okay, so for example, let us try to play around a little bit. You see, when I am changing, so the lines, everything is changing, but not the 90-degree angle. So that was the claim we were able to prove. Yes, is that clear? So that is what we proved. Yes.
How did you put the angle on?
The 90-degree angle. So I chose this one. Yes. So in order to have an angle, you need to have 3 vertices. So this vertex was not clear yet. So I went to the intersection part. I found the intersection between these 2 purple lines. And then I click here, click there by having this on. Then it will give me the angle. Okay. So that was what we proved. Okay. So I don't know, if you play this around, it will play by itself. So you see, everything will change, but not the angle 90 degrees. Okay, so that was something that you proved, yes? Okay, is that understandable? Okay, so that was a good problem. But I was thinking that we can start solving some national exam questions now. So somehow related to the chapters that we have studied. Okay, so if you don't mind, let me fix. So let us see how many of these questions, not that many yet, but these are the questions. So you can, but of course, this has changed, as I told you, but more or less the points are the same. Yeah. Okay. So there are 60 points. So you see the passing is not that high. And even C is more or less 50%. Okay, so these 2 grades probably are a little bit competitive. Okay, so but I want to wait for you to solve the problem. So you see the first digital tools are not allowed, only answer is required. Write your answers in the test booklet. Okay, so just do it. Okay, you can do it. I'll wait for you, I don't know, 3 minutes at most. Okay, so let us solve the problem, yes? So what matters, I want you to understand, so you will receive a scratch paper. For these questions, you have to do whatever you need in the scratch paper and then write the complete final answer there. Be careful about that. So if I go to a scratch paper, I want to calculate sine of 5x. So which formula is relevant? In the formula sheet, you get this formula. Sine x derivative is what? Cosine x. This you will see it in the formula sheet. But that is not directly suitable for this problem, yes? Because that is not sine x, it is sine 5x. But we practice a lot about this. What we should do, we need to use the chain rule, yes? So you need to understand the chain rule version of this one yourself. What is the chain rule version? Instead of x, you write u. You follow the same rule, pretending that u is x. Yes, but you have to multiply by u prime. Okay, so that's exactly what's happening. In the formula sheet, you have this. You need to understand this one yourself, and then use this, taking this u in your head. The answer becomes cosine of what? If I take the derivative, it becomes cosine of u, which is cosine of 5x, multiplied by 5x prime. And what the answer is? This is just 5. And when you want to write it down, don't write it in that way. So what is the answer that you have to provide here? The answer is that they have written, by the way, f prime of x. Do not write f prime of x anymore. So what I need to write in that blank, I write 5 first, multiplied by cosine of 5x. This and only this will bring you 1 point. Okay, so we don't care how you did it. You did a scratch paper. Yes? Is that clear? Okay, what about the next one? The next one, the same story. Which formula is suitable for this? The formula that you will see in the formula sheet is x to the power of a prime, which is a x to the power of a minus 1. Okay? But for this one, what I need, again, what do I need? This formula is not x to power 10. It is something else to power 10. If it was just x to power 10, I know what to do. It is not x to power 10, so you know what to do. What I'm supposed to do, you need to write x to the power of 10. You read it from the table, which is this. And now you have u to power 10. Then the answer becomes 10u to power 9 times u prime. So I take this one to be u in my head, yes? And then I take the derivative. So 10 goes down, u to the power of 9, but it is not finished. You have to multiply by the derivative of u. What is the derivative of this? 5. Don't write 5 like this. You have to multiply 5 there. I told you that if you don't write it like this, you will miss the points, even though you have done it correctly. So this becomes 5, multiplied by 10, write it 50, and that's the answer. So the answer that you have to provide here is 50, 5x plus 2 to the 9. Yes? Be careful, you have to simplify and put the answer there. What about this one? This is the rule that we learned in recently. So what is, and they are giving you a hint by putting this dot. Sometimes they might not put the dot there, you need to understand. It means which rule is suitable here? It was the name was product rule. Okay, and then you will see the product rule in the formula sheet. So you need to find it. F dot G prime is the derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one. So you go to a scratch paper, you write x to the 7 multiplied by x derivative. So according to this rule, it becomes the derivative of the first one multiplied by the second one itself plus the first one itself multiplied by the derivative of the second one. But the derivative of the first one is in the table. It is 7x to the 6 e to the x. You don't need even to put the dot here. And the derivative of e to the power of x is still in the table, but you hopefully remember that. It is this one. And you don't need to do any changes. Okay, you just put it there. So it becomes 7 x to the power of 6 e to the power of x plus x to the power of 7 e to the power of x. Okay, so this will bring you 3 points. Any questions so far? Yes?
What if we factorize out EX?
So I will take my own responsibility. I think they will be flexible for that. Okay, but don't do extra things. So this is not extra thing. If you just write 5 there, 10 there, you should multiply. That's not very extra thing. But when you got the derivative, if you factorize it, it's still correct, but it is not needed. Okay, so don't worry about those nuances. Don't try to just solve the problem. Okay. Any questions here? Okay, so by the way, this is the new lesson that we had. But let us go to a little bit older lesson. This is trigonometry we learned in the first chapter. Okay, that's extremely simple again. You know, the function f is given by this rule. Write down the period of the function. Write down the least value of the function. Okay, so I want to wait a little bit for you. Okay, so can you answer this? This is a very standard function, yes? Do you remember? I don't know, if you study a little bit, that's what I'm saying. You have to remember everything until May, okay? So this, the period of this function, do you remember what was it? And they haven't mentioned, by the way, express it in radian or degrees, but let us take it radians, okay? So what should I do here? Do you remember the formula? The period is 2 pi divided by which letter? B. Do you remember what B was? B was this coefficient here. Yes? So it is just 2 pi and B is 4. But don't write 2 pi over 4. You will lose the point. You have to simplify if it is possible. So what is the answer? Pi over 2. Okay, so that's it. That's the answer that you have to put. By the way, this is a scratch work. And then what I expect you to write there is just pi over 2, nothing else. Even you don't need to write t. Okay, because they have write down the period of the function. Okay, write down the least value of the function or the minimum of the function. So what is the least value of this function? Yes?
-3.
Minus 3. Why? I hope that you remember. What is the maximum value of cosine? 1. What is the minimum value of cosine? -1. You want to minimize this. If you want to minimize this, do you choose the biggest value for cosine or the lowest value? Lowest value. So the lowest value, so you go to a scratch paper, you write 2 plus 5. The minimum value for cosine is -1. So what the answer is 2 minus 5, which is -3. And what you write there is just -3. Yes? But this is not always the case. For example, let us test your understanding. If this was given, so what is the minimum of this function? It's still -3. Okay? But in order to reach the minimum, you have to put the maximum for cosine. So don't get confused, yes? Because I want to make this as low as possible. Because this is negative, if I want to make the whole combination minimum, I have to maximize this so that the difference make it minimum. Okay, so you need to understand, might be they can change these things a little bit. But these will bring you 1 point and 1 point. So far you got 5 points in a matter of 3 minutes, 5 minutes, okay? It's not hard to pass, I just tell you. Okay, let us go to the next question. That is a little bit annoying question. Might be will not be able to answer it right now, but you know what to do, okay? So let us read it. The figure shows the curve y equals to sine x. So that's the standard one. And a point P. The point P lies on the curve and has y coordinate 0. As you see, of course, on the picture. They're just explaining it. Write down the x coordinates of the point P. Give your answer in radians. Okay, I want to wait for you. Because the other part is sketch the curve. It is not hard. It's very simple. Okay, but let us wait for you to do this one. Okay, how we solve the problem? Okay, it's very easy, isn't it? You don't need to do anything. I don't know, of course, it depends how much you remember. For example, if I ask you what is this number here, because you see this is the standard sine function. What is this number here? What? Pi. Because we start from 0 and we reach to a maximum. When do we reach to a maximum? Do you remember? Sine is the y coordinate, yes? So here we have the unit circle. I start from 0 and I start increasing my angle. So the y coordinate increases up to this point, which is 90 degrees. In radian is pi over 2. And then after that, it will actually goes down again, okay? Up to here. So if I start from 0, the y coordinate becomes 0 again here. But what is this angle? Pi. Is that right? So this means that by looking at the picture, you see that this is 1 pi. Yes? So this becomes 2 pi, 3 pi, 4 pi, 6 pi, 7 pi. So 1, this is 1, 2, 3, 4, 5, 6. So I lost the point. As simple as that. Yes? So be careful. Yes. So this answer is just 6 pi. Yes? You put there and then you get your point. But if you are careless like me, you lose the point. It doesn't matter how much you know mathematics. Yes? Okay. So that is just 7 pi. Okay? That's again 6 pi. I'm insisting to lose that point anyway. Okay, but now the second one is also not hard. They sketch the curve this in the coordinate system as an 8. The curve is already been drawn here. So they have given you the same curve but in a dotted form, and they ask you to draw the sine of x over 2. So you need to remember that lesson that I was talking about, the effect of multiplying the x by a number, the function by a number, and things like that. Do you remember that? So what is the effect? So sine x over 2 means what? So x over 2 means sine of 1 over 2 times x. So if you have forgotten, of course, you have to review for the exam a little bit. Do you remember we talked about this scenario? If I have a function, I can multiply a number outside, I can multiply the number within the x. So this is the case that we are multiplying x with a number. So what was the effect? The effect was either a stretch or a squeeze along the x direction. And I told you, remember, x direction always work not very natural. So here you are multiplying, you expect that it will be shrinked, but it will be stretched. Yes, by a factor of 2. Is that right? So if you have forgotten, of course, I tell you that the only thing that you have to be good at to remember things. Okay, so but it is a very simple problem. So what you have to do, you understand that you have to stretch the graph by a factor of 2. So you start from here then, but instead of having this maximum here, you double it in size, you will have your maximum here. Yes, so this graph will go up to here, yes, and then comes back again, and then, so this graph will start here, goes to maximum, double in size, and then it goes back here after 2, okay, and then it goes and be doubled here. So you can just draw it yourself. It's very hard for me to do the mouse, but that is, you just draw it and you get a 1 point. So you just stretch it. The only thing is that you remember, if a factor of 1 over 2, many people actually squeeze it. But remember, x coordinate acts differently. Okay, but that's it. Yes? Okay, so that was also done. So far, how many points we collected? So 1, 2, 3, 4, 5, 6, and 7, hopefully. Okay. Yeah. But the next lesson, we haven't learned that yet. Not yet. None of them we have studied yet. Okay, let us go here. Now, digital tools are not allowed. Write down your solutions on separate sheets of paper. So here, not only the final answer is important, but also the solution is important. But as I told you, that you will not have these type of points anymore. Okay. Okay, I want to wait for you to solve this one. Sine of 4x is equal to a square root of 3 over 2. So let us see. At least you can help me to solve this. Do you remember? There is, unfortunately, I told you that for trigonometric equations, you do not have the correct formulas in the formula sheet. So you need to have it in your mind or find it from scratch every time, which I don't recommend for the exam. So do you remember what I had written for you? I had written sine of a box equals to a number k. For this box, we have two options. Either sine inverse of k plus n times 2n pi, if I want to write it in radians. Or another option is what? Do you remember?
180 degrees.
180 degrees, which of course in radians is pi minus plus 2n. Okay, so these are the options that you have. So what you do, you give the role of the box to this one. So box is 4x is equal to sine inverse of this number. This number should look familiar to your eyes. Otherwise, you will not bother to see the formula sheet. Okay? So if this number looks familiar to your eyes, there is a big table at the end of the formula sheets, then you see that this angle is 60 degrees. Okay? So it becomes 60 means pi over 3, and then plus 2n pi. Okay, this is extremely simple. You divide by 4, becomes what? 12, and then you divide this by 4, it becomes n pi over 2. And then of course you say that n is an integer. So that is one solution. And the other solution is this formula. So 4x is equal to pi minus the same number, pi over 3 plus 2n pi. But pi minus pi over 3 can be written as 2 pi over 3 by just common denominator, and then you divide by 4. So what happens? 2 pi over 3 divided by 4 is pi over 6. and then you have n pi over 2 again, and that's another answer. N belongs to z. Yes? So 3 more points. It's very simple. By the way, this one of them is a C point probably, according to their standards. So, understandable? Okay, so let us see how many other questions we can solve here. Okay, so for example, this question, hopefully you know what to do. Number 15, show that this one is equal to this one. That was, when I was teaching you, that was under the title of trigonometric identities. I'll wait for you because you can solve all these 3 problems. And then you are on the safe side. So it takes only 30 minutes to pass. Okay? Not hard, because 2 points, 3 points, 3 points, it gives you how many points? It gives you 8 points from here, 3 points there, 11, and 7 points there, so it's 18. So now if you just solve 2 pieces of paper, so in principle you can pass the exam right now without even studying integrals and anything else. Okay, so what should we do for this one? Do you have any suggestions for me? Yes? This is an identity, so I want to show that the left side is equal to the right side. So I start from the left side, but can you tell me what to do? There is nothing guiding us that much because the right-hand side is very simplified, so we don't know what to do. When we don't know what to do, there is one thing to do. What is that?
Maybe if we write them the same
Denominator. Yes, let us see. So what is the same denominator? The product of these two. Do you agree? Okay. But now I have to start rescaling. The denominator was this one. I wrote it like this. So it means that I multiplied that denominator by that. I have to do the same thing to its own numerator. So I take the numerator of that one and multiply it by the extra factor that I multiplied its denominator by. This becomes cosine x plus sine x. Then I have a plus sign here. And now I compare this new denominator with the old one. I see that this old one is being multiplied by this factor. I have to do the same to its own numerator. So I will take the numerator and multiply it by that extra factor. By the way, each one of these parts will give you some points. Okay? So the next part, what do you think I will do now? It is simple. What should I do in the numerator?
Factorize sine x. Factor out.
You can factor out sine x. If you do that, that is correct. But the natural way is to multiply. So it is up to you if you take the factor. So I will usually you multiply and simplify. So this becomes sine x cosine x. But what you said is also correct. Plus sine x squared. And then I multiply this. It is sine x cosine x. Yes, and I multiply that, it minus sine x squared. And then the denominator, what can I do? What? Conjugate. So it becomes cosine x to the power of 2 minus sine x to the power of 2. I haven't seen the domain for this yet, but I'm sure that you have gotten some points up to here, even if you don't complete it. But then, of course, if you reach here, completing is not hard. This one and that one are gone. And I have this combination plus the same combination becomes 2 sine x cosine x. And then the denominator is this one. Okay, what do you think I will do from now? Yes, so that is important. I don't expect you to remember the correct formulas, but I expect you to remember these things are famous in trigonometry. If you don't know the exact, you can go and find the formula. Then you see this is the formula for the double angle of sine. So it becomes sine 2x. And exactly below that, you will see this formula is for cosine of 2x. But can I go further now? I have sine of 2x divided by cosine of the same angle 2x, which becomes tangent of 2x, and we are done. So it was not hard. So far 12 points. 3 more points and then we relax. Okay, the next question. This is one of those questions I told you, if you go back to your notes, probably I told you put a star somewhere on it. The angle V satisfies the following conditions. Sine V squared is 8/9, and V is between 90 degrees and 180 degrees. It is in the second quadrant. And then you are supposed to find tangent. That's exactly one of those problems that when I was teaching, I told you put a star on it, not because it is hard, because it is important. And that's exactly the same thing. So they are giving 3 points for it, and not E points, 3 C points. Okay, so do you know what to do? So sine V squared is given to be 8/9. And by the way, when they say determine, they should emphasize determine the exact value. So no, they don't need to do that because you are not allowed to use the calculator in this part. So there is no way for you to even find the approximate value. Okay, so V is between 90 degrees and 180 degrees. And you are supposed to find tangent of V. So again, think logically. The strategy I told you is always useful. What is the question mark? Don't let this information distract you. Your goal is to find tangent of V. So what is tangent of V? You go back to your toolbox. How can I find tangent of V? So you can do this in a scratch paper. Tangent of V is sine V over cosine V. Do I have problems for this one? No, because sine V to the power of 2 is given. So in principle, I can find sine V. So I am relaxed about this. What about cosine V? That's the only problem. I need to find cosine V. And I hope that you remember the famous formula. What's the famous formula in trigonometry? Yes, sine V squared plus cosine V squared is 1. But this one is given to you. 8/9 plus cosine V squared is 1. I am looking for cosine V squared. So what happens? Cosine V squared becomes 1 minus 8/9. But if you calculate that, it becomes 1/9. So you have to write these things. In that case, you have to explain. So cosine V becomes plus or minus square root of 1/9 is 1/. Yes? But which one is acceptable? That is the reason they have given you this. So V is in the second quadrant. In the second quadrant, if you imagine cosine is the x-coordinate, is negative. So you need to explain a little bit. In the second quadrant, cosine is negative. So I will write this. You need to write this down, okay? This is cosine. But I need also sine, but that's also simple. So sine becomes what? Plus or minus the square root of 8/3. But again, in the second quadrant, cosine, sine is, if you imagine sine is the y-coordinate, is positive. You explain this in a little bit of words, and then you say that this is 8/3. And now my question mark is tangent of V, which is sine of V, divided by cosine of V. And this one and that one are simplified, so the answer is minus the square root of. Okay, so another 3 points. It was, you see, it is not hard, but this is not important. When I explain it, it is not hard. You need to ask yourself, could you solve it without me? That is important in the exam. Okay. Okay, one more problem we solve so that we are certain that we pass. Okay, so the function f is given by this, and 2 informations are given. Determine constants a and b so that f of 1 is 4, f prime of 1 is 3. Very straightforward question. Okay, so let me write this here. A function is given to you. Depends. Oh, here. So f of x is given to you. F of x equals to ax plus b over x plus 1. And then they have given us that f of 1 is 4. They also have given us the f prime of 1 is 3. They are asking what is A and what is B. And I told you that you don't need to solve this problem completely. Even if you solve one part reasonably correct, you get some points, which is very important. So what is the first thing I want to do? I have to use these two pieces of information to find A and B. Which one you start? I always start with simple ones to be a little bit more relaxed. I will start with here. F of 1 is 4. What is the meaning of this? It means that if you go to your function, replace x with 1, the answer is supposed to be 4. Yes? So I would write in the exam, f of 1 is 4. This means I replace x with 1 is 4. I replace every x with 1. But 1 plus 1 is 2. I multiply everything by 2. I get a plus b equals to 8. I'm sure that you get 1 point for this. Okay? And now you want to use the harder one. How should I use the harder one? F prime of 1. You learn how can I calculate f prime at a number? First, I have to differentiate and then replace x with 1. That is the meaning of f prime of 1. Okay, so then your point is how to differentiate. Then you need to look in your toolbox again. Which tool is suitable for differentiating this? What is the name of that tool? Yeah, the quotient rule, yes? So if you know that's quotient rule and you don't remember it, you go to the formula sheet, you see this quotient rule there. F over G prime is F prime G minus FG prime over G squared. Okay? So you patiently do that. So I will come here, F prime of X is, according to that formula, the derivative of the numerator. We don't need to be in a hurry. Multiplied by the denominator itself minus the numerator itself multiplied by the derivative of the denominator and divided by denominator is squared. So far I just used the formula. And then the derivative of this one is, what is the derivative? A, so it becomes A x plus 1 minus the derivative of x plus 1 is 1, so it becomes the same thing. So be careful about not messing up minus signs. And then the denominator is squared. You don't even need to bother to raise it to power 2. Just keep it like that. This is nothing. It's on the board. And then I simplify a little bit. I multiply A. I multiply the minus sign. It becomes minus AX. Be careful. Minus B. And that minus B is very crucial because if you miss that one, you will get A plus B again. That is problematic, okay? And then you have x plus 1 to the power of 2, and then this one and that one are gone. So eventually that is my derivative. F prime of x is equal to A minus B, and the denominator is x plus 1 to the power of 2. So this is your derivative. And I think if you just do the derivative correctly, you also get some points. Okay, but now f prime of 1 is supposed to be 3. F prime of 1 means go to f prime, replace x with 1, the answer is supposed to be 3. So f prime of 1 is 3. What does this mean? It means that when I replace x with 1, these parts you can do it in your head, okay? The answer is supposed to be 3. But 1 plus 1 is 2, 2 to power 2 is 4, 4 times 3 is 12. So a minus b is 12. On the one hand, a plus b is 8. On the other hand, a minus b is 12. This is the simplest possible system that you can solve, yes? So you can set up a system. The first equation is a plus b equals to 8. The second one, a minus b is equal to 12. Okay? And then, for example, I add these two. It becomes 2a is equal to 20. So a becomes 10, and b becomes minus 2. Yes? So you see that for just passing, we just passed even more than needed, okay? You don't even need to know other chapters. So you just could pass with the knowledge that you have. Any questions? So of course, we will practice the national exam a little bit more. Especially, I want to go to that part that you have to use GeoGebra. Okay, so that is also very important. Any questions so far? Okay, thank you.